right, we're diving into math today, but hang on, not the kind you're probably picturing from school. We're going to see how all those abstract formulas actually connect to something real, the world that's all around you. Ah, yes, the classic question. We've all been there, right? Staring at a whiteboard covered in X's and Y's and just thinking, what does this have to do with my actual life? And you know what? It's a totally fair question. Today, we're finally going to answer it.
See, this is the fundamental disconnect. Over here, you've got the pure language of math, all symbols and equations. And over there, you've got real stuff we do every day. The trick has always been, how do you build a bridge between the two?
So how do we build that bridge? Well, what if I told you the solution isn't to change the math, but to completely flip our perspective on how we learn it in the first place?
I mean, really think about that. Instead of memorizing a formula and then desperately trying to find a problem it fits, what if we did the opposite? What if we started by just looking around us and learning to see the math that's already there, working behind the scenes?
Well, this way of thinking actually has a name. It's called applied mathematics. And it's not some new, complicated type of math. Nope, it's a completely different way of using it. It's about treating formulas less like rules you have to memorize and more like tools you can use to figure things out.
And to really see what this looks like in action, we're going to explore a curriculum that just completely nails this idea. It's called Applied Math Mastery, and it's all about bringing this philosophy to life for young students.
Okay, so let's get into the nitty-gritty. How does a program like this actually work? What does it look like when you teach math not from a textbook, but from the world itself?
Now, this program we're looking at, it focuses on grades 5 through 8, and that's no accident. These are those really crucial years where a kid's confidence in a subject either takes off or it kind of crashes and burns. It's often where you decide if you're a math person or not. So making math relevant here can change everything.
And this is the magic right here. Forget chapters on fractions or geometry. The learning is built around real places. So for example, when you're in the kitchen, you're not just learning fractions. You're figuring out how to double a recipe that needs 3/4 of a cup of something. All of a sudden, math isn't a worksheet. It's the tool you need to make sure the cookies turn out right.
And this is so important. The goal isn't to make up silly word problems about two trains leaving a station at different times. It's about training our eyes to see the math that's already woven into the fabric of the world, to see the geometry in a spider web or the physics in a free throw. The source material just says it perfectly. The whole method is to visually overlay the equations and symbols of math onto everyday activities. Just picture it. You see the formula for area pop up right over a pizza as someone's cutting it, or an equation for percentages appearing over a sales sign in a store. It makes that connection totally obvious and immediate. So, okay, that's the how, but let's talk about the why. Why does this matter so much? Because honestly, the payoff here goes way beyond just getting a better grade on a math test. It's about building a whole new mindset. See, when you learn math this way, you're not just learning how to crunch numbers. You're learning how to solve problems, how to think critically, how to look at the world through a more analytical lens. You're building a mental toolkit that you can apply to literally everything. And this path right here really shows how it all comes together for a student. It all starts with that one little aha moment when they see the connection. That spark builds into a real intuition for how things work. And from that intuition, they get confidence, which is the absolute key that unlocks that final step, being able to take that skill and apply it anywhere they want. So when you put it all together, the benefits are just massive. This isn't just about making better math students. It's about creating more curious, capable, critical thinkers. And best of all, it finally gives a good answer to that age-old question, when will I ever use this? The answer? Literally every single day. And that leaves us with one last big thought. We've been talking about math, but just imagine if this same idea was applied everywhere. What if we learned history by exploring our own towns, or science by planting a garden? What would change if the goal of school wasn't just to know things, but to see, to connect, and to apply them? Really makes you think, doesn't it?